PQR is lying on its circumference and its center mark O. RP is the diameter of the circle and AB is a tangent to the circle at P. Angle R is 2x degrees. Angle RPS is x degrees. Angle QSP is 54, all of which they put on the diagram. Determine the value of each of the following, and you need to state how you got your answer. So working out the value for x. Now the first thing is the center of the circle. What that means is the line RP is a diameter. If RP is a diameter, then we can clearly see that PO is a absolutely right. I delayed to say it, but PO is a radius. And the angle between a radius and a tangent, we know that is 90 degrees. Angle between radius and tangent is 90. Then this angle right here, let's put it on the diagram. We know that all of this angle is 90. All right, so what we then know is that 5x, 2x plus 3x, 5x is 90. So therefore, we'll divide both sides by 5. X would be equal to 90 over 5, which is 18 degrees. So the answer is x equal 18 degrees. What's our reason? We're going to give them the reason here. The reason is because angle between a tangent and a radius is 90. All right. So angle between tangent and the radius is 90. So we can tell them that 2x plus 3x equal to 90. So hence x has to be 18 degrees. All right, that's the reason. The angle between the tangent and the radius is 90. All right, no problem. Want to tell them that angle x is 18 degrees. We're okay now, so we'll call it that. Let's look at the y. Now, how are we going to find angle y? Now, to find angle y, look at this. It's no trouble at all. I'm going to use let me use the color green. Look at this triangle right here that I'm going to put on in green. RS, S to P, P to R. Look at this triangle right here. What do we know? The angle at S is what? 90 degrees. We know that this entire angle is 90 degrees because angles in a semicircle is 90. Angles in a semicircle is 90. So all of this angle right here in yellow, the entire angle, even with the 54 in it, we know that's 90. All right. So we know all of that angle is 90. Then the angle X, we already know X is 18. So now we know two angles in the triangle and we need to find Y. So we know that Y is equal to 180 minus the other two angles that we know, which is 90 plus 18. So 90 plus 18 is 108. 180 minus 108 is 72 degrees. So that's angle Y. The reason for it is that angles in a semicircle sum to 180. Angles in a semicircle sum to 180 degrees. All right, angles in a semicircle sum to 180 degrees. Now, once you work out that angles in a semicircle sum to 180 degrees, you can even add another reason and then tell them, hence, since we already know that the other angle was 18 and angles in a triangle sum to 180, hence y 72. But I'm not doing all that talking. If you write this, that is sufficient. Now we need to go ahead and find angle Z. So let's go back and find angle Z. So angle Z now. Now, if we know this triangle, if we know this angle to differentiate the triangles, I'm going to use purple. So look at this. If we know, then from Q to P, then from S to P, we know those angles in that triangle right there, right? We already know that this angle is 54. This small piece is 54. And we know that X is 18. So if X is 18 and this is 2X, 2 times 18 is 36, and 36 and 18, this is also 54. Since this is 54 as well, then we know that Z is going to be, we can subtract those angles from Z now. All right, so what we're saying then is Z is equal to 1 over 8 minus X, but we already know that X is 18. So it's 1 minus 54 minus 3 times 18, and when you put it in a calculator, simplifies this to this. Now, maybe you would have quickly observed and said, but sir, why didn't you just do same segment theorem? If you want segment theorem, that's perfect. Fine. I said angles in the same segment are equal. Angles in the same segment are equal and perfectly fine if you use angles. I just to you. So the reason that I am using this is angles in a triangle sum to 180, because that's the first reason that popped out to me. So angles in a triangle sum to 180. So that's the reasoning behind of Z. All right, no problem. All right, now that we completed that part of the question, let's move on now to part B. Part B, it says the diagram, let's zoom up a bit. So part B says the diagram below shows the straight roads connecting the towns L, M, and N. L, M, and N, and R. LR is 18 kilometers. Then they tell us that LN is 12 kilometers, MN is 10 kilometers, angle RLN is 25 degrees, angle LMN is 88. Calculate angle MLN. Angle MLN. So this is the angle that we need to find in here, the angle at L. Now, in order to do that, we're going to use sine rule. So remember sine rule, the side that matches it. So this angle would correlate, let's call that angle X, right? That angle corresponds to the side of 10 kilometers, the side opposite from it. So we can say that the sine of X over 10 is equal to the sine of an angle that we know 88 corresponds to 12 kilometers. So it's equal to the sine of 88 over 12. So now we can cross multiply and say, therefore, sine X would be equal to 10 times the sine of 88 over 12. You go ahead and you put that into your calculator. So let's put it in our calculator. 10 sine 88 divided by 12. That works out to be 0.833. So sine X works out to be 0.833. So now X is going to be sine inverse of that. So sine inverse of that is going to be, so you're going to take out your calculator and you're going to sine inverse it now. So sine inverse the answer. and you're going to get 56.4 degrees. So angle MLN works out to be 56.4 degrees. So sine inverse that number, it's 56.4. And we'll put on our degrees. That's the answer right there. Easy stuff. Now the next part says calculate the distance NR. Calculate the distance NR. This is the distance NR they're talking about. This distance. In order to find the distance NR, notice we have two sides and an angle in between it. So you're going to use cosine rule. So cosine rule, remember, it is then going to say that NR square is equal to the first side square plus the second side square minus 2 times the first side times the second side times the cosine of the angle in between them. And the angle is 25 degrees. So you're going to put all of the right hand side in a calculator one time. So 12 square plus 18 square minus 2 times 12 times 18 multiplied by the cos of 25. All of that in a calculator one time gives us 76.47. So NR square is equal to 76.48. So NR is going to be the square root of 76.48. So we're going to square root it, and that's going to give us the distance. So square root the answer, and we get 8.75. So this works out to be 8.75 kilometers. That's your answer. It didn't say to give to the nearest kilometer or anything. So this side, we know that's just 8.75 kilometers. And that's that right there. All right. Beautiful stuff so far. No issues at all. All right, that's 8.75. Now it says determine the bearing of tone R from tone L. Bearing of tone R from tone L. So from tone L, this is the point L. So we're going all the way around here. So all of this angle is going to be, notice, bearing of R from L. Here is the north. They even give the north line for us. This is the north line. So R from L, it's all of this angle here. Let me put it in yellow. So it's going to be 50 degrees plus X plus 25. So in that case, the bearing is going to be 50 degrees plus X, and X was 56.4. And then we add it to, finally, the 25 degrees. You put all of that into your calculator, and that will be the answer. So 50 plus 56.4 plus 25, that works out to be 131.4 degrees. This works out to be 131.4 degrees. That's our answer. All right, that is our answer, 131.4 degrees. That is our answer. Really nice stuff. All right, so now we're at question number 10. Question number 10, it says 3 points OP and R are shown on the grid below. O is the origin. Write the position vector of R, OR in the form AB. So write the position vector of R. So R, as you can see, R is this point right here. And what is that X value? The X value, that point R would be 5, and the Y value is 1. So in position vector form, it's going to be 5, 1. Now, they tell us that another point Q is located in a way so that QR is 2, -4. Using information, plot Q. Now, if QR is 2, -4, remember that QR is equal to vector of the last, so OR, minus vector of the first, OQ. Now, already know OR. OR is the point 5, 1. And we already know QR. They told us QR is 2, negative 4. From that, we're able to find vector OQ. Vector OQ is, we don't know, right? So let's just leave it unknown for now. Let's just leave it as OQ. So if we make vector OQ the subject, transpose it. So we're going to bring OQ to the left and bring 2 minus 4 to the right. That is going to give us, I'm just going to zoom out for a second. So zooming out, so we can write on the screen here. So vector OQ is then going to be equal to 5, 1 minus 2, negative 4. Now 5 minus 2 is 3, and 1 minus negative 4, minus and minus become plus, so that's plus 4. 4 plus 1 is 5. So OQ is the point 3, 5. So we're going to put on 3, 5 on our diagram. X is 3 and the Y value is 5. So 3, 5 is somewhere right there. That is a point Q. All right, that is 3, 5. Cool. Now that that is the point 3, 5, what we're then going to do is, I don't know. Let's hear what the question have for us. The question says now, determine the magnitude of QR. Now, the magnitude of vector QR. Now, the magnitude of vector QR is really the length of this line. All right, that's really what they're asking for, the length of QR. But the magnitude of vector QR, the magnitude, that's just going to be equal to the square root of, it's going to be the x component square, QR, the x component square, that's 2 square, plus the y component square. Y component square is negative 4 square. So 2 square plus negative 4 square. You put that in a calculator, 2 square is 4, plus 4 square is 16. 16 plus 4 is 20. So the magnitude of vector QR is equal to the square root of 20. That's your answer. All right. Now it says, show by calculation that OPQR is a parallelogram. OPQR. It says, show that OPQR is a parallelogram. So let me just draw it to see if it connects up to be a parallelogram. O to P, P to Q, Q to R, O to R. Now, guys, in order to show that it is a parallelogram, what we know about parallelogram is that a parallelogram have 2 pair of parallel sides. I'm going to zoom in again. This is our parallelogram right here. A parallelogram have 2 pair of parallel sides. So we need to show that this side is parallel to this side, or you can show that this side is parallel to this side. That's what we know about parallelogram. A parallelogram of 2 pair of parallel sides. So we need to show that OP is parallel to QR, right? So what is OP? Writing down vector OP, look at it. Vector OP is equal to, look at it here. Vector OP is X value is negative 2, Y value of 4. OP is negative 2, 4. I'm positive that was vector RQ. That's vector OP. And look at that, vector QR is 2, negative 4. So we're good. Look at this. So this is how we're going to show it by calculation. So by calculation, OP is equal to negative 2, 4. And we need to show that it is parallel to vector RQ. Now, as we can see, they already gave us vector QR. Also, vector QR is equal to 2, negative 4. And so therefore, vector RQ would be equal to the negative of this. The negative of 2 will be -2, and the negative of -4 is +4. Now look at that. Since they're both the same, therefore, this is a parallelogram. So what that means is, therefore, OP and RQ is going in the same direction. So therefore, OP is parallel to RQ. So hence, OP, RQ, or OPQR is a parallelogram. So remember the properties of a parallelogram. A parallelogram have two pair of parallel sides. You didn't have to use these two sides that I used. You could have used the two sides, PQ and OR. But I decided to use vector OP and vector RQ. All right, you just need to show that both of them going to be the same. So OP, so in order to prove that's a parallelogram, you could have showed that OP, vector OP is the same as vector RQ, or you could have showed that vector PQ is going to be the same as vector OR. Any one of them would show that it's a parallelogram. That would be the proof of proving parallelogram. All right? So anyone you could have used to prove your answer. Now that's the one that I chose. Now part B says calculate the value of X and the value of Y in this matrix equation. So the value of X right here is first row by first column. All right, so to get X, we notice that it's in first row, first column. All right, so in this case, we can say 1 times -4 plus 5 times 2, that's going to give us our value for X. So in this case, 1 times -4 is -4, plus 5 times 2 is 10. That is X. In this case, 10 minus 4, that works out to be 6. So X equals 6. That's your answer. Now, in order to find the value of Y, there are many ways you can find Y. It depends on which way you want to go. You can go second row by first column to give the third element here. Remember this one right here is going to be second row times the first column. You can use that one. So in that case, you would say 2 times X. Sorry. In that case, you would say 2 times -4 plus Y times 2 is equal to 6. From that, you get -8 plus 2Y is equal to 6. We bring over the -8 to get 2Y is equal to 14. And so Y is equal to 7. You could use that equation, or I'm going to change the color and say that you could have used this equation as well. You could go with this point. If you're going with that number right there, you'd end up say row by column, you'd say 2 times 46 plus Y times 9. Why do I have 46 there? My apologies again. Please, 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 please bear with me. All right, I'm looking too far ahead. It's 2 times 1 plus 9 times Y, or Y times 9. That's going to be 65. In that case, we bring over the 2, and that would say 9Y is 63. And then we divide both sides by 9, and you'd still get Y equals 7. So anyway you decide to do it, guys, it's really up to you. I'm just showing you both ways of which way you prefer to find Y. Whether you prefer to do it in the red or whether you prefer to do it in yellow, you still get Y is 7. So the answers are X equals 6, Y equals 7. All right, now the next one says a transformation T is represented by this matrix equation that maps X S 2, 5 to the point S prime, which is 5, 2. Describe the transformation T. Now, guys, clearly from what you see right here, the X get exchanged with the Y, and the Y get exchanged with the X. That's going from S to S prime. So if we're exchanging the X and the Y, right? Then this is clearly a reflection in the Y, reflection in the line Y equal to X. This is a reflection in the line Y equal to X. So this is a reflection in the line Y equal to X. That's all. All right. Once you see that you're exchanging the X and Y, that's all we're doing. This is just a reflection in the line Y equal X. All right, because the 2 becomes a 5 over there. That's it.